Sorry about that. So let's back up. We're decompiling Castlevania Symphony of the Night. Go to soten.z.dev and you can get an overview of where we are in the project. Status for any of the overlays. Links to GitHub and Discord. GitHub, you can find the code that we've committed, as well as information on Discord. So what I was talking about when I was alerted to my audio issues, last week we were working on an Entity Maria cutscene and got pretty close. I think we were 98, 99% match there before the stream ended, and then I ended up finishing that off at the end of last week. One of the things of note was there was this pointer to a rectangle which is passed to move image. Do I have slow mode chat activated intentionally? No, I don't. Honestly, I don't know what slow mode is. So it's probably a setting that I have to look at. Anyway, this pointer, I added a stack variable and was setting that to a rectangle that was also on the stack up above, but that instruction didn't exist to set that variable. What I found after looking at the PSP version and this version, this is actually a just a dangling pointer. So this rectangle in the PlayStation version is a pointer to nothing. It's never set. So whatever the stack variable or whatever the stack value is that this gets assigned to when this function is called, that's what that rectangle will be pointed to. So oftentimes I looked a little bit at the arbitrary code execution, and what you're looking for there is, are there places that we can kind of control writing to memory for some other effect later on? And this potentially is one of those places. So in the PlayStation version, this pointer will be pointing to whatever value the last function that called was, that set that stack address to some value. And then we're manipulating it down here, not knowing specifically where it's pointing to. And in the PlayStation version of the game, it must be pointing to somewhere relatively safe because there aren't any crashes or other artifacts related to this. But it is a bug, and the MetroWorks compiler catches that bug and gives you a warning, and so they fixed it during the PSP version. Oh, interesting. No, I don't have that set intentionally. Let me see if I can do something about that. Oh yeah, slow mode is set for 30 seconds. I've lowered that. If there's spam or other things that get put in, I'll take a look at that again. And now I need to figure out how to get back to. Let's get back to chat. Yeah, I haven't gone through and looked at that in a debugger to see what it might be referencing. And yeah, that particular cutscene is relatively constrained, so there's probably low likelihood that it's vulnerable. But it is interesting to go through, and I actually in this scratch, it's a little different from what I ended up submitting in PR. I have the pointer version specifically set for PlayStation or version US, and that's because this code down here shouldn't be what other versions of the game execute, especially when porting later on. we want a correct version of that game. Oh, all kinds of Twitch things that I know. Look at that. All the commands, all the commands. All right, so let's get back to the Sword of Dawn. I didn't really look at this yesterday too much, but looking at the PSP version definitely was an improvement over the other. I think what we'll do is start trying to get rid of as many of these variables as possible. I think reducing that will probably get us some quick wins. The other thing that I mentioned when audio was broken earlier was at the beginning of last stream, I spent some time looking at the make config overlay tool that was just added, and looked at adding the center stage to the overlays for the HD version of the game. And what I found when adding an additional overlay, we have a lot of code, and the way that we're building overlays, we're compiling any C code that happens to be in the directory for that overlay, whether or not that C code is actually used to build that overlay. And so you get into some funny situations where you have one version that's fully decompiled versus a version that's not, where you require then a lot of if-defs and other things like that. And there's some more work to be done there that wasn't ready to be checked in. I thought it was closer than it was, but I ended up pulling that PR last night. All right, so I want to look at several of these where we have variables that are commonly constants, or might be something different than we're expecting. If the Sword of Dawn animation gets annoying, please call it out, and I'll pause it. So this virus4 is the color lookup table, so I think it makes sense to replace that variable. Get a nice name there. And let's look at virus3 as well. So these are U and V are the X and Y for texture maps. So this virus3 here can probably just be called V. That doesn't help our match at all, but it makes things easier to follow. Okay, so we're yesterday when we were looking at this, we have some things that are being stored on the stack versus registers, and that's one of the reasons I want to clean up some variables. As we reduce variables, the register pressure lowers, and I'm hoping that the MetroWorks compiler then is going to start moving some things from the stack into registers. Does it match to PSP2? Which one? The Maria cutscene? Actually, yeah, there were differences between the PSP version and the PlayStation 1 version of that Marie cutscene. I used the PSP version to get through some of the the issue is just figuring out how the PlayStation 1 version works. I didn't go back though and make it fully PSP compatible. So there's going to be more work that's done there. Okay, so let's keep going. So I want to get down to when we see moves and stack differences. I'm not too concerned about that. I want to look at this here, this var v1. So this looks like it's just I times 8. Let's see if we can find where those instructions are over here. So I think that was pulled out during the GCC decompile. And so we should be able to get rid of all of that. Let's see where we are there. So a few things here. Setting offset 36. These are usually out of order. And that helps there. Sometimes I'm too fast for the compiler. Actually, it's an issue with decomp.me. Not an issue. Decomp.me will pull for changes, and if there hasn't been any changes in so long, or it'll send it back to be recompiled. And then when, if you happen to make changes within that window, your changes won't necessarily be recompiled until you make another change. So this looks like potentially an ordering issue, and that's what happened here as well, which can be a pain. So this is a similar issue. Oh, Control J, thank you. That'd be a Command J on a Mac? Yes, Command J. Odd key combo. I need both hands on the keyboard to do that one. All right, so this was an ordering issue, and again, we have the same kind of issue here, where we're loading a stack value when what we expect to do is be getting that from a register. This temp v0 is not being set, so let's try to figure out what that is. So we have this same S8 register in the original, which is V. It looks actually very similar. Except the I+1. This seems different enough that it's possible that the PlayStation version is doing something different here. I did miss an add 1. All right, that looks good. And so while it's noisy, all these register differences is not something that I'm going to focus on until more instruction matches are finished. This temp v0 _2, that can go away now. So I'm going to scroll through and try to find any obvious differences. Register differences, like I said, I'm not worried about. Stack differences, I'm not worried about. Down on line 186, we have differences there. So here we're doing, yeah, and I looked at this a little bit. Here we're doing some, a lot of temporary variables that look to be related to collider not actually being a stack variable by itself, but possibly being an array and accessing it through array index here. This is actually going to be somewhat of a mess to clean up, but it needs to be done eventually. So we have var s3 underscore 2 here, and then var s6. This pointer math seems odd to me. If we look at the size of a collider is relatively large. So offsetting 2 of these appears to be an odd pattern, especially when that's something that's going to be on the stack. When I did go through these, so basically we're looping through this for loop 8 times, and each time what we want to do is send a different collider in. And a collider is a structure that basically tells us whether there was a collision between the objects passed in, and that's our output value. And then those collider values are looked at further down. There's actually another loop that sets them again, but then much further down, there's some checks against each one of those colliders. So I think what I'm going to do is declare collider as an array. I might create a new array called colliders, and then start kind of incrementally moving things over from the single collider reference to using that array, and see if we're getting closer or further. That's going to mess up the stack offsets even more. But again, I'm not too concerned with that. If I would just replace collider right away, there's lots of other references there. I am going to get rid of this var 6. Because that'll help me find all the areas that need to be updated with the correct thing. So all of this up here, and it kind of shows in the assembly as well, we're doing a bunch of this reference arithmetic that isn't necessary. Actually, this is necessary. Don't listen to me. So we may be taking a reference to the second element of that collider array. And then incrementing that pointer. So let's make a collider pointer. I'm not sure yet why. We'd be starting with the second element. And what is it not liking? Oh, my variable is called colliders. And so now we can go through and find all these var S6s and start getting rid of those. And see where we are. So here we're going to be just looking at our collider pointer. I'm going to go with the assumption here that we're looking at the same pointer, even though there's a +1 there. And I don't remember what the number was. What are we at before? This is way, way lower. Part of that is because of completely obliterating the stack by doing that. Let's look at our instructions, though, and see if we're a little closer. So this is not any better here. This var s3_2, I think all those are just references to pointer as well. I'm going to assume. And if we have to back out this change, that's fine. I'm not overly committed to it. So var_4_2 and var5, these are, I believe, are XY. These are being stored, it looks like, as 32-bit values. And so let's see if we don't have 32-bit X and Ys. Oh, maybe it is just 16-bit. The sign extend, this SEH, sign extend high, that is where I got the assumption that it was a 32-bit value. But assigning it here, does not seem to give me the instructions that I want. Let's get back to where we were. Oh, that does. I must have missed it along the way. So here we're seeing some load words versus pulling registers. Unfortunately, that adds a lot of noise, but it's not not something necessarily that we can deal with yet. This var s5, let's see here. We have the same pattern here, so I'm going to replace that with y32. Oops. I'm not sure right now if this is an issue with pulling the value from the stack versus in a register. None of what I want to do is seeming to make much of a difference, though. Yeah, collider P would be what I would expect, but we're seeing an odd. So this is going to be A2, and the way A2 is being loaded is through an add versus a load word with an offset. Which so the offset is yeah, so is this does it take a reference to a pointer? Yeah, I don't so it does look like this is a reference to a specific collider. I'm not sure why we're maintaining this collider pointer then, and that maybe this is that whole thing was a red herring. It possibly a rabbit trail that I shouldn't have gone down. So in general, that looks better. There's still, I think, some stack versus register differences. I'm not going to worry about those again. And a bunch of noisy variables. So it looks like Y32 is getting updated here. Let's see if we can straighten this out. We have a sign extension. So this was arg0 up above. Oh no, it's being being loaded there. But as a 16, this may be done first. Yeah, but the store isn't being done. May or may not be, again, register versus stack assignment. I'll go back and kind of clean those up later. So switching those other variables did give us the stack back, or sorry, the register back. So let's try doing that all inline again. Okay, so Bismurphy's thinking that we're just looking at the one collider. So let's get rid of that then. Let's look at 184. Collider P we might not even need. Yeah. And let's then look down here on line 207. If we're not using the collider pointer, what is what was generating those instructions down below? Actually don't see anything. So yeah, it looks like those were just superfluous. Hallucinations of the decompiler. All right, so we have a shift left. So that's the same as a multiply 4. Of S2. And we're doing that on line 197 as well. So these are, again, kind of happening in registers that we're not allocating at the moment. Let's kind of go from the top again and see where we are. So A0 appears to be getting set fine, but out of order. Again, it's on the stack versus in a register. Is it possible that these are just X? Possibly. Let's look at Y32. And if we just make all these Y32, oops. Is that going to clean this up? So what I'm thinking about is there something that's more structurally wrong with this than just stack versus registers? When when we're doing sign extensions from one register to another, basically we're just converting 16-bit values to 32-bit and making sure that the 2's complement signed version of that value is maintained. When we're pulling that value from the stack, however, if we've allocated 32 bits for it already, it's just going to be what it is. I'm gonna keep going from this, and I'll come back to it later. So there could be types of these variables that are incorrect. Tweaking those and playing around with that is something that could be done, but I think there's likely other things that we can do along the way. So here on S2, I think we figured out was Y32. In this case, it's not, however. Maybe it is. Let's look at offset BC, which is our value on the stack, versus S2. And what we want to see is everywhere that we have offset BC on the stack being used where S2 is. And that does look pretty consistent. That actually elevated one more use of it, elevated it to be important enough to be stored in a register. So that's helpful because now we can go back and see where else we may have gotten things wrong. There's a bunch up here that now we see as not correct. So S2, actually, S2 appears to be our I and not Y32. I don't see anything else. So one of the things that Biz Murphy points this out on the stream in the past, and I generally find to be true as well, is MetroWorks tends to not reuse or tends to assign the same variables to the same registers. In this case, though, it does look like this Y32 that's being set on line 184 is temporarily using the S2 register before getting shoved into a 0. And then S2 is being reused for I down below. So when we see S2 in the target assembly, that should be a hint to us to use I instead. And our I right now is in S4, but those are starting to match. So as we kind of go down and see where those are changing, we should start seeing things match up there. So here there is a store to a different offset. I'm not going to worry about that at the moment. I'm primarily going to focus on making sure that these get updated properly. Oh, that's interesting. Our register now got changed to S3. And we were looking for, I think I saw that highlighted on this side, but let me check over here. I don't. We are looking for things with offset BC that are I don't think that was correct. So Biz Murphy's pointing out that the unknown 20 may be writing to buffer instead. I will try that in a bit. But I'm actually going to move past this section. So we see another section down here that's effectively the same or very similar logic, and we can check this as well to see are there some of the same issues with this that there were before, or if it gives us any hints as to what's happening above. So I think these are basically going to be the same, using x32 and y32. And again, it's possible that these are actually 16-bit. So the cast here to 16-bit and then a cast to 32-bit is somewhat of a hint that it should be treated as a 16-bit value before using it as the type declared for the function. And we could try that to see. I'm going to keep going for now, though. We see a similar construct here to above. I asked in one of the earlier videos if people liked, should I move on or should I stare at code and try to work through it? There's a YouTube comment that said, one vote for staring. I'm not sure if I'm as keen on that. Hey, Nate the Great. Good to have you back. I don't know if you were on Thursday, but I talked a little bit about your arbitrary code execution video. I can't remember if I mentioned that, if you were on or not. I tried setting up the environment to do it, but that was beyond my skill at the moment. So we're probably going to have a similar thing down here too, with where these are being set against our I value as opposed to something else. And kind of like Biz Murphy said, these could be being set on the buffer instead. And what was our buffer? Isn't S32. It looks like that buffer probably should be a 16-bit. And that would get that to work out. Where's this additional add for the stack pointer coming from? Yeah. Something else going on there. I'm just poking at things though. These var S6 and var S3, those are superfluous. Are they? Maybe they're not. Oh, they're not. Yeah, this isn't the right logic. There is a some additional probably very similar to up here that is missing, but not quite. Not quite. All right, so let's kind of break this down. We're taking our I value, multiplying it by 2, and then so this does look like something else related to the buffer at I, and we are storing that to S5 and then branching down to 70. So this looks like there's additional condition that is missing from this particular if statement. So let's look at where we're branching to. 708 and 760. So quite a difference here. Sorry, my brain isn't thinking. So what I'm looking at here is we have a branch up here We're branching to relatively different locations depending on that condition. So 760 versus 708. Our offsets are different because there's code missing in one, that's the other. So we can't expect those values to be the same. But when we look at our diff between the target and our current, those should line up relatively closely, and they don't. There's quite a few instructions that are happening here that should be happening above. And unfortunately, my brain is not working well today, and I'm kind of missing what those might be. So when you say it exists on PS1 and PS3, the PS3 software emulator, or the PS3, like the original PS3 that had full hardware backwards compatibility? And if so, would it work on a PS2? Or even a PSP playing the PlayStation Classics version of the game. I'm gonna move past this point. Dr. Thunder. We're drinking Dr. Thunder. Only the finest of fake Dr. Peppers. I did get some prickly pear wheat ale that I enjoyed a lot earlier this week. So I do enjoy Dr. Pepper. What I learned, though, a long time ago, I think Pib Extra is the better fake Dr. Pepper. That's sacrilege, and it definitely does not have the branding of Dr. Pepper. To me, Pib Extra tastes like what Dr. Pepper tasted like when I was a kid. All right, so I'm gonna move down. I have other things on my mind, and so I kind of want to get back to some more mindless, less thinky decompile, more mindless decompile. So this loop label is not being used. This block is not being used. There's some weird indentation here. So we have a child entity being created. Let's rename that entity. And let's scroll down and see what is going on down here. Okay. So the first thing is we're creating a child entity, and when the decompiler comes through, we have this extension field on an entity structure, and it's a union full of a lot of different things. And basically, any entity can use this however it wants. And so we have to figure out what the correct field of that union should be your member of that union. And so in the code here, we're looking at offset 9C. That's the value that the decompiler will put in if it doesn't know what type that is. In this case, the generic extension is just used for things that we don't know what it is, and oftentimes the decompiler will choose that instead. I actually just changed this a few days ago. So that is acceleration X in the weapon type. So we often, when weapons are creating child objects or child entities, following the weapon type makes a lot of sense. Here it's being cast as an entity. The only reason that was happening was because the decompiler chose that field of that type, and that's what it ended up being. So it was an entity type, so the decompiler wanted to coerce that value of 1 to that type. So let's go down to line 172 and just make sure that that all looks correct. So, okay. I was wondering why a B was there. We're loading immediate value 1, yeah, and storing that at the correct offset, so that looks fine. Another question I got asked on YouTube, which I thought was interesting, was how do people play? The question was, how do you play the game? And I took it as like, well, I'm relatively methodical and cautious, so I go through and just kind of explore and have fun. I think what they were asking though was like, what system do you play the game on, or like, what way do you play it? And then I had to think, like, how have I played Soten in the past? I think I mentioned before, the first time I played it was the Castlevania X collection. I was playing on a Vita. I had been interested in the game for a while, and the Castlevania X collection would frequently be like $2 or $3 in the PlayStation Store. And so I bought that version, and I think that was the first one that I played. And I played that again on, I picked up a PSP Go a few years ago, played it on that, and like that cramps your hands when you're playing. And then I have played through the PlayStation version at least once. And then, let's see, picked up the Requiem collection. I don't know. It's a great game for portable systems, I think. Even though it was made for consoles, it works really well on portables. Any preferred ways? Do people prefer the original PlayStation version versus the PSP version? I've read. It seems like people who like the Saturn version typically aren't the people who play it. I don't know if that's actually the case. So we have a. We'll get the correct symbol name here from the PlayStation version. But it looks like whoever I forked this from, it was an Anon that I forked it from. They had commented a bunch of this out. So we're loading some offset from memory. It looks like it probably is a byte array. And then loading something at offset 0 of that. So either the 0th element or a field at offset 0. So let's go back to the PlayStation version. Actually, it probably would be not the worst idea to see if this is getting us any closer. It's actually getting us further on the PlayStation version as well. That's okay. Sometimes you have to step back to go forward. Let's get back to this section over here. Too far. So now I'm looking at the PlayStation version. So we're loading this value, and let's uncomment this and see what instructions we end up getting. So we don't know what this type is yet, so we'll give it a type. It looked like a array of bytes. So the address here okay, so this kind of trying to digest what was originally written here. So they're taking a reference to some offset into this array, multiplying that by 2. So you're taking a pointer value and multiplying that pointer value by 2. Pointer multiplication typically doesn't make sense. Usually you're adding some offset of the size of that pointer. But then they're adding it to the pointer of a collider that's on the stack, and then taking a field from the amalgamation of all that stuff. In general, that's not very sensible. But what would be sensible? So let's break that down and see if we can get something that seems more correct. Oh. All right, so we have our load. V0 is going to be this, whatever this structure is. And so the original is making it seem like a byte array, but it looks more likely that the first field is a byte. And then we have some additional data coming from offset 68. Is that right? V0, S0. S0 is... S0 is our collider. So I think we're taking... let's look at the decompile. I'm not confident enough to speculate on what this is doing. Okay, so this is Yeah, this is where all this was coming from. So this was, yeah, part of the original decompile. Let's actually take this back. So this is, it's compiling, but it's not great. We'll take this over to the PSP side and work it out over there, because that that's going to be more straightforward to work out. All right, so we have our load. So we're loading S2, and if S2 is the same as what we had before, that was I. Ours is being called S3, and that's fine. We're loading a byte, which is correct, except we're loading an unsigned byte, and the original was a signed byte. Shifting left by 2, which is the multiply by 2. And then adding a value from a value right at the stack pointer. But then we're storing that as our entity position. There's this addition at the end for collider effects, I don't think is correct. But the rest of it, I think, is fine. So what this value down here is, I think, is wrong, and we'll need to figure that out. This unknown 98 then basically is getting the same value, and that'll have to be fixed in both places. But we're doing the math again. It might be slightly different. Yeah, sorry. Unknown 98 is just getting set to this other value. And now we're going to do this again, except we're going to be subtracting 19 from this value for the I. This will probably end up being slightly different. But I think this is getting relatively close to what was there. These unknown 9.8 and unknown 9a values here. These are, I think some of the weapons actually have them commented that they are an alternate X and Y. Hey Aldrich, good to have you. And so then we have this final one down here for weapon unknown 90, and it's actually 92. This was something that I changed as well recently. In these offset 90 through 90, 92, 94, 96, we had 32-bit values there before. And when we were talking yesterday, I said, what if these were 16-bit values and not 32? And we looked through all the existing weapon implementations to see whether or not that was possibly the case. And there weren't any weapon implementations that were using offset 90 as a 32-bit value. And so it was able to be split into two 16-bit values. And that came from doing this work. So we have one additional chunk here. It looks very similar. And our store is ultimately at offset 70 of A2. And that's this offset from the stack pointer. Oh, this may be the, is it the same buffer that we were dealing with earlier? Let's go up here on line 94 and see if our buffer, if that could possibly be the same thing. It's not. That's a bummer. And what is the type of our buffer? S16. So this is somewhat interesting here. So this came from the PlayStation version, but it looks like that buffer is actually a 32. It doesn't change much, but it's a little closer. Sorry, I'm jumping around quite a bit. Trying to figure out whether or not that is relevant to our code down below here. All right, so let's look at this line. Our store here is going back to 9A of ours is V1. On the original side it was A0. And so we do need a store on 92. So yeah, it does look like 92 is getting set, and then a modulus is being taken. And so again, this isn't quite correct, but it should align the instructions a little better. And then we can go back through and later on and figure out what it was. So we're missing a load here of immediate value 1. And that immediate value 1 is ultimately added. Let's put it up front. And my guess is that that is in place of this one down here. Not quite, not quite. So we're missing a. So this is a multiplied by 4, which is a shift by 2. We're loading this value from the stack, which doesn't exist in the original. But we are adding the stack pointer value, which again, it's unclear what. I'm not sure what that is yet. But then storing back eventually on line 92. And where's this add 1 coming from? Here our store is actually at offset 70. Let's look at an entity and see what offset 70 is. So it's in an unknown field. Is this? Yeah, we are setting it. So we're setting it to a 32-bit value. And we're setting it to this result. So we have to do some tricks to coerce this into the type that we want. So we're going to say that we have a signed 32-bit pointer, and we are going to dereference that pointer and set it to this value. And it looks like I'm off by 1 or 2. $62. Okay, there we go. I just want to make sure our no, yeah, no, that's wrong. That's wrong. That's wrong. It's not offset 70 of the entity, but offset 70 of whatever's at the stack pointer. Oh, so this possibly is, yeah, setting another value on the buffer. Okay, that's why you want Bismurphy on your stream. So that's where the shift is coming from. So our buffer has 32-bit value, 32-bit values, and that gives us our shift left by 2, which gives us then the address there. Yeah, and so that ends up explaining a bunch. There's a, let's see, where's this A1 being used? So we do have a, looks like a temporary variable that's being assigned before all of this happens, and then being added down below. So loading an immediate, I'm going to use x32 here because I know it's available. And then I can add it down here. Oops. But we can switch what that is later. $278. So So we're incrementing this value and then taking the modulus, set. So we're just doing mod equals 6 here. So this this assignment here, was this necessary? Possibly not. Where is that A being used? So ours is S6. It is being used down below. 77. Start buffer. No. I'm missing where this is being used, but it is being used. It's actually being overwritten, right? So we're loading S6, loading immediate value 1, but then it's being offset 70 is overwriting that value. And then yeah, there's something else going on that I'm missing. Yeah, this this load seems superfluous. It may or may not be related to something, but we'll move on and see if it works out later. Should it be there? Should it not? I don't know. But we will figure that out in a bit. So then towards the end, we have some additional things that are being stored. So offset B0. Basically, we're setting up some register values for the next iteration of the loop. And let's see if we can figure out what B0 is, if it's used elsewhere. I don't see it being used elsewhere. Oh, here we go on line 239. So that is our weapon 90, unknown 90 field. This is somewhat interesting. In the original, it looks like this is actually part of an else our value down here is part of an else condition. So we're if this condition is false, we're going to be branching down below all of this. Where are we going? We're actually going to be branching up to 64C, which is up here on line 214. So it looks like this actually is probably part of the same loop. And so if weapon unknown 90 is already greater than 0, we're going to continue that loop. Otherwise, we're going to do this other work. And that, let's see where we were here. Oh, I screwed that up. So that how this branch is working is I'm having all kinds of problems today. I'm not reading this quite right. This does look like we should be jumping down to this lower area, not based on a condition, but unconditionally. So typically that is either the end of the positive side of a condition, or something else, because basically we need to get past code that's coming later on that would be part of an else block or other things like that. So there's some logical errors there that need to be worked out. I'm running up on time though, so I'm gonna close this off today. Thanks for struggling through Weapon 30 with me today, which is the Sword of Dawn. We'll get through it. Not every day can be a banner day for decompiling, and this one certainly wasn't. But it's fun, and I definitely enjoy getting to do this with you, and getting to decompile in general. What a world we live in, where we can take our favorite games and get back to some source code smoothly or not smoothly. So we were decompiling Sword of Dawn for Castlevania Symphony of the Night. We have 2 functions left in the main weapon overlay, or weapon 0 overlay, which consists of the first 58 weapons, I should say first 58 weapon implementations. That consists of around 100 plus weapons or so, which share those implementations. If you want to know more about decompiling Castlevania Symphony of the Night, go to soten.z.dev. You'll find the progress that we've made on several of the overlays, a link to source code, a link to our Discord server where we're talking about all kinds of things. If you enjoy the game, Enjoy decompiling. No C, no MIPS assembly. Want to contribute? Stop by the Discord and somebody will help you get set up and get going. If you don't know any of those things but still want to chat, we have rooms for ROM hacking, information about the game, lots of other things. I'm here typically Monday through Thursday. I'm going to take the rest of the week off, and I'll be gone the first part of next week as well, so I'll be back a week from tomorrow, so Wednesday of next week, and we'll see where we are, see if any progress has been made on weapons. Will they be finished? Won't they? You'll have to tune in to Made Up of Wires next Wednesday. Again, thanks everybody for stopping by. Really enjoy the chat. Really enjoy just participating in this community. All right, see you in a week. Adios.